Hello everyone. My name is Hirobumi Tomita from University of Tsukuba. I'd like to talk about a proposal and investigation of displaying method by passive touch with electrostatic tactile display. Introduction. In the field of haptic displays, electrostatic tactile displays have been developed for presenting tactile stimulation. The display consists of a high voltage generator, an electrode, and an insulator. When the high voltage is applied to the electrode, the user feels the tactile stimulation by rubbing on the display. However, the tactile stimulation is not presented when the user stops moving the finger. In this research, our goal is to present the tactile sensation to the stationary finger with an electrostatic tactile display. For realizing our goal, we employ a parallel plate electrostatic actuator mechanism. This mechanism consists of two electrodes, non-stationary electrode and a stationary electrode. Then, the surface of the non-stationary electrode is covered with an insulator film. When high voltage is applied to the stationary electrode, the attractive electrostatic force occurs on the non-stationary electrode. By changing the input voltage, it is possible to vibrate the non-stationary electrode. We realize a vibration display under a passive touch condition with an electrostatic tactile display using this actuator. A tactile display based on this actuator had already been proposed. Pyo and others implemented an electrostatic actuator by using PDMS with an embossed structure. However, two high voltage power sources are required, and electrostatic actuator using PDMS require a high voltage. Thus, we proposed a tactile display using an electrostatic actuator mechanism with a lower voltage and a simpler structure. The left figure shows the conventional method. The right figure shows our proposed method. We created a small space between an electrode and an insulator by using small diameter cylindrical electrodes. By applying a high voltage to the stationary electrode, the insulator and the surface of the finger are considered to be closer to the stationary electrode. Furthermore, by changing the voltage, the surface of the finger vibrates, and our device allows the user to perceive a tactile sensation. We used a stainless steel fiber as an electrode. These were arranged in vertical stripes and covered with a polyvinylidene chloride insulator film. Next, we held an evaluation experiment to explore whether the user can feel tactile stimulation by using constant stimuli with non-university students. In this experiment, we changed the voltage amplitude of input waveforms and asked the participants to answer whether they felt the stimuli presented on the tactile display. We prepared 3 waveforms, sine wave, square wave, and delta function, and 10 types of dominant frequencies from 10 to 630 Hz of each waveform. Furthermore, we prepared 9 voltage amplitudes from 200 to 600 voltage. We conducted these experiments while keeping the pressing force of about 40 or 80 gram force. we instructed them to keep it constant. Each parameter was displayed 10 times. From this parameter, participants conducted 5,400 trials of evaluation. In this experiment, white noise was applied to participants using a headphone during the experiment for masking the external sound. Participants select the answer by using the installed keyboard. We instructed them to place their right index finger on the tactile display. In this evaluation experiment, we investigated the perception threshold of each voltage amplitude by using constant stimuli. So we collected evaluation results from the participants and obtained the percentage of responses that answered felt at each amplitude. We calculated psychometric function with voltage amplitude on the horizontal axis. In this experiment, a voltage where the psychometric function went across 50% of the perception rate was set as the threshold. By calculating the threshold of every waveform, we can observe the trend of the voltage threshold. This figure shows the result of the voltage threshold in each input waveform. The horizontal axis shows the frequency of the input waveform. The blue line indicates the condition of a weaker pressure, and the orange line indicates the condition of a stronger pressure in these graphs. From the result, the availability of the tactile display without moving a finger is confirmed by using our proposed method. Furthermore, we found two characteristics. Almost all thresholds appear to be smaller under the weak pressure condition than under the strong pressure condition. And the graphs of sine and square waves are downward convex with a minimum value around 200 Hz. The graph of the delta function is gradually rising or declining. Regarding the pressing force, we confirmed that the evaluation result differs depending on the pressing force. We considered that the factor of this result is based on the ratio between the pressing force of the finger and a just noticeable difference. We focused on Weber's law. From this equation, the stronger the user presses, the more the amount of stimuli is needed. Therefore, we consider that the threshold becomes higher when the pressing force is stronger. Regarding the trend difference of graphs between waveforms, the outline of the graph differs depending on the waveform. The reason is considered to be related to the frequency components of each input waveform and the frequency responses of human mechanoreceptors. For example, a low dominant frequency square wave and delta function still contains high frequency components. So we consider that these components stimulate the mechanoreceptors. Conclusion: we propose a method that can display tactile stimulation without moving a finger with an electrostatic tactile display. We explored whether the user can feel tactile stimulation under several conditions. From the result, the possibility of a tactile display without moving a finger is confirmed, and the voltage threshold differs according to the pressing force and the waveform. In the near future, we plan to clarify the modeling of tactile perception using our proposed method. and to investigate the difference in the width of tactile expression compared with the conventional method. Thank you for listening.